Okay, dear friends, so this we are solving right now paper 6-2, and it is from May-June 2023. As scheduled, we know time is 1 hour for this question paper and marks are 40. And you people are having the original papers with you, so you will be following the instructions quickly and using your paper which I gave you in the printed form yesterday. Now, a student investigate the stretching of a spring. Figure 1.1 shows the setup. So you can see ruler is there. The length LO, the value LO is the length of the spring when the load is 0. So this is unstretched length. In other words, you can say the original length. Unstretched length, or you can say the original length. Then, my dear friends, next is the student measures the original length of the spring. She records LO is equal to 16 millimeters, and it is written equal to 16 millimeter, and that is mentioned in the table. Draw a diagram of the spring to show clearly the length LO of the spring. Draw a diagram. So what to do? We can draw the diagram accordingly. So it can be done on the diagram, same diagram, or you can draw a separate diagram. So if you ask me, draw a diagram of the spring to show clearly the length LO of the spring. So in this length, we are not going to use the hook's length as we discussed. So here I'm just sharing with you people like this one and this one. So only this is the length of the spring which we can measure. Now see, if you want me to draw it here, see, that is the hook. Then so here show clearly. So what can you do? See, from the arc, this one, and even then here, if you want, you can show even a meter rule very close to it, which is vertically upright. So this will be the length LO. Like this you can share it. You can share it. Okay, hook's length will not be marked. Simple as that. Next is, now if any one of you is having a problem, please feel free, you can ask me, but it's simple, easily you can understand it. But excluding the hook's length, only the coiled length we are always using, and here also we will be using the coiled length. There is nothing special, just one mark, so you can manage it roughly and solve it. Okay, dear students, next is, now calculate the extension E of the spring for each load using the equation E is equal to L minus LO. Actually, the student started with initial load 0.20 Newton, then she repeats the procedure using 0.40, 0.60, 0.80 and 1 Newton. The readings are shown in table 1.1 and formula is given, and we have to calculate E. Now one thing should be very clear, that all the lengths which are with load, they are L, and which is without load, that is LO. This is the original length. Now calculators are with you. Pick up your calculators. Here it is very simple. 18 minus 16, it is simply 2.0. 21 minus 16, 5.0. 23 minus 16, 7.0. Please correct me if I'm wrong. Then 24 minus 18, that is 8.0. 26 minus 16, 24 minus 16, actually I was supposed 26 minus 16, it is 10.0. Please, anybody, if there is any problem, Feel free, you people can ask me now. Now load, see, next is complete the column headings in the table. So load is in Newton, length it is in millimeters, and extension is also in millimeters. As I told you yesterday, how it is millimeters, see the reading from the theory, we can get the units mostly. So 16 millimeter LO, original length, when no load is attached, and when there is load attached, that is the stretched length. Now in this case 18, 21, 23, 24, 26, these are all loaded lengths or stretched lengths. Only 16 centimeter is the unstretched length. Plot a graph of load on y-axis against extension on x-axis. No worries. So we will be writing here load but with unit in newtons on y-axis, and extension but that is in millimeters. Be very careful, in on x-axis, and we scored our first mark. Now we need to scatter the data. Load is from point 0, 0 to 1. So no problem, we can start from origin. This is 0, 0.0. Here it will be 0, 0.20. This one will be 0, 0.40. Next value 0, 0.60. Then 0, 0.80. And this is 1.00. All the values of load are done. Now extension 2 to 810. So what can we do? Starting from, of course, 0, then 2.0, then 4.0, then 6.0. This is what 8.0, and here this is what 10. Now we scored our second mark also. The reason for that, more than the data of extension is covering more than half of the grid on x-axis, and similarly the given data for load, it is also covering more than half of the grid on y-axis. So our second mark is scored. Now we need to locate the points. So first line, of course, this will be here 0, 0. Then when it is 0.2, so load is, when load is 0.20, extension is 2.
Mister, I have a question.
Sorry?
I have a question. In the question, it didn't say like to start from 0, 0. So is it okay if I didn't start from like 0, 0 and just started from
So how will you
0.20?
justify the graph here, daughter? Then okay, please share with me your scale even. He did not say anything. Mostly graph is starting from origin in general. When you have not to start from 0, 0, mostly they are mentioning that no, you have to start from, you are not supposed to start from 0, 0. If not said, and see in this way, it is so nicely data is scattered on more than half of the grid. So this is some sort of practice will help you out. But here there is no reason that we should not start from 0. So next is 0.4 and then 5. See, 0.4 and 5. Where is 5? 5 is between 4 and 6. So it means this point. Then add 0.6, it is 7. 0.6, this is 7. 0.6, see, this is 6, this is 8, so 7 is of course here. Then my dear friends, next is 0.8, that is 8. 0.8, this is 8. No, not a proper point. Again. Yes, now fine. Then next is 1 and it is 10. At 1 it is yes, like this. So now you have to draw a straight line. So I don't have the scale smaller one, so I will be doing it roughly here. Just a minute, let me take one scale. Akbar. So this will be thin well judge line. We are not going to draw a line which is just making something. This will be my line. The reason for that, if I'm trying to join all the points, it will be not a curved line. It will not be a straight line. So what to do? I can go with a straight line as I have drawn in front of you, but this is well judged line because 2 points are up, 2 are down, and well defined line is there. Now, after this, what should we do? Use the graph to determine EA extension produced by a load of 0.5 Newton. Show clearly on the graph how you obtain the necessary information. First of all, 0.50 Newton. So it is of course here in between. This is 0.50 Newton. So what we will do, straight line this way till it touches the graph here, and then my dear friends, let's go down this way. Now we will check what is this value. See, in the center of course this is 5, so then 5.2, 5.4, so I will say this is 5.4. so extension simply is equal to 5.4, but don't forget that it is in millimeters. It is in what? Millimeters. So answer is, by the way, range of the answer is from 5.0 to 5.4. so our answer is within the upper limit. Five is wrong. Answer in the mark scheme, that is 5.2 plus minus 0.2. So it means your line is not a well judged line as I have done. Maybe you have tried to connect all the points. No chance. There is no possibility that all the points will be connected in this one. So just a well judged line. And what is the well judged line? See, whatever the distance of these points above the graph, almost same for these points below the graph. So even if I was moving it little bit up, that was even more suitable. Or in this way even it's okay. So well judged line. So maybe you are getting 2 marks, not 3. In this case, if your answer is, what did you say? Wait a minute. What did you say? I got 5. Yes, 5 is correct. Yeah, range is from 5 to 5.4. Sorry, Mariam, it's okay. No problem. Fine. So this was question number 1. If there is any other question, please feel free and you people can ask me now. You will not know. You have to, mostly the curved line is Coulomb curve in your syllabus. Sometime for the line between angle of incidence and angle of refraction, if it is not fulfilled, so that can be, but mostly Coulomb curve is there, that will be curved in general for most of these questions related to spring. Then yes, this will be straight line, and curve line is no chance in general. Curve line, no chance in general. Okay, my dear friends, now let's move forward. That is the question, the cooling of water. In this case, student investigate the cooling of water. Figure shows the setup. So lid is there, bench, beaker, thermometer, everything is there. The thermometer in figure 2.2 shows the room temperature theta r at the beginning of the experiment, record theta r. So 20, 21, 22, 23. So 23, but don't forget to write degree Celsius. If degree Celsius is not written, you are going to get 0 mark, not even 1. Then the student pours 200 centimeter cube of hot water into the beaker. He places a lid on the beaker. He places the thermometer in the hot water in the beaker. Then he records in table 2.1 the temperature theta of the hot water at T is equal to 0. He immediately starts the stopwatch. So he continues Continues recording temperature in table 2.1 at 30 seconds interval until he has 7 sets of readings. Complete the column headings in the table 2.1. Here time is in seconds, temperature is in degrees Celsius. Write the times in the first column of table 2.1. He records the temperature theta of the hot water, T is equal to 0. So this is 0. Then at 30-second interval, 30 plus 30, 60, 60 plus 30, 90, 90 plus 30, 120, 120 plus 30, 150, and 150 plus 30, 180. This is, I think, the replica of yesterday's question, almost same stuff. Calculate the decrease in temperature delta theta, T is equal to 0 and T is equal to 180. So it is 92 minus 75. So 92 minus 75, answer is equal to 17 degrees Celsius. 17 degree Celsius. So this is the answer. Calculate the average rate of cooling R of the water using this equation where delta T is 180. So delta theta, it means 17 over 180. 17 divided by 180, which is 0.094444. So 0.094, include the unit. So no problem. Degree Celsius is the unit for temperature here in this case. Second is the unit for time. So unit will be degree Celsius per second. Unit will be degree Celsius per second. A student states that the water cools slowly. State 2 changes to the experiment that the student makes to increase the rate of cooling of hot water without changing the starting temperature of the hot water. Room temperature also remains. Mean we are not making any change with the temperature. Either initial, mean either the room temperature or the initial temperature of water. What can be the changes made? Many things we can do. First of all, he put a lid. Remove the lid. Increase the surface area of the beaker. Yes, Mariam. Okay, first I will go with this one. I will say use a wider beaker. Also, you can say remove the lid. Many you can see. Even keep on stirring. That will also be affecting the answer. Mean keep on stirring continuously. It will be increasing the rate of cooling of water. Then state one precaution that you would take to obtain accurate temperature readings. Accurate temperature readings. Okay, so very simple. Many times I told you, view the scale of thermometer at 90 degree. Why? To avoid parallax error. Avoid parallax error. That simply can be the answer. Temperature readings are as accurate as possible. Or as I told in some previous question that the thermometer should not be touching, the bulb of the thermometer should not be touching the beaker. So why so? Because the temperature of the beaker will be different from the liquid. So that can be the explanation in this case. Okay, so now the last one is, this is bit a question out of the way. The student uses the measuring cylinder to measure 200 centimeter cube of water. He takes the reading from the bottom of the meniscus. Explain the reason for taking the reading at the bottom of the meniscus rather than at the top of the meniscus. there is very small difference in difference in volume between top and bottom of the meniscus. So in a safer side, we don't want to take more volume of the liquid or water. We are a little bit small volume of the water we are measuring actually, because lower level of meniscus and upper level of meniscus, there will be not a very big difference of the volume of the water. So on a safer side, we are always going with the bottom of the meniscus. Please, dear friends, if there is any question further, feel free. You people can ask me now. Okay, so this first half of the paper is done. Next half, inshallah, in the next recording. Stay blessed.